Good morning, everyone. My name is Jacqueline Johnson, and I am a candidate for the Math Professional Development Specialist position with Eureka Math. This morning, we are going to go through some information in the 6 to 8 grade band that supports us reviewing collaboratively how to build algebraic fluency through tape diagrams. Okay, so a couple things just to get started. I've been a math teacher in the classroom for a little over 6 years. One of those years was in France, actually a teacher. That was not a math teacher. I was teaching English in France and came back, worked a little bit in a few counties, and finally spent some time, long time in Baltimore City schools, supporting middle school girls actually with learning mathematics. Since then, I've been an instructional coach and instructional specialist and started my own consulting firm. Where I support teachers, school leaders, and is also networks and districts with understanding and carving out a vision for mathematics. So there's a little bit of teacher in me, a lot of it, and only a little bit of presenter. So I'm going to put on my instructor role, and you put on your learner hat. That would be awesome. Before we get started, a couple of norms to be mindful of. In order for us to make this a safe space, I call it a risk-taking space, we want to be mindful of a few things. So the first thing we want to do is assume positive intentions. We want to assume that when people assert ideas or challenge others, that it is for the greater good of supporting us with supporting students. Second, we want to make sure that we are present. There is nothing worse than feeling like you have a team and half the team is checked out. Third, we would like to challenge each other with a notice phrase or wondering phrase. I think that supports us with not judging each other, rather challenging statements, ideas, or agreeing with them. Okay. Number 4, we want to consume technology with professionalism. I'll leave that as that. If you have to handle something related to your school, your job, your family, please feel free to do so. If you'd like to tweet about the session, please feel free to do that. This is the age of technology. I would like you to remember number 2, which is to be present, and don't overconsume the technology. We will have technology breaks throughout the day. And number 5, please have fun. We are all here to learn. We are here to support each other. And just as we would want our kids in the classroom to enjoy, we want to do the same thing. So with that said, let's review the session goals quickly. Can I have someone read that for me, please? Participants will understand the use of a tape diagram to aid students in algebraic fluency and modeling of word problems. Thank you. May you call on any one of your colleagues here to support reading the second one. Thank you. Participants will be able to guide a struggling student through the modeling stages of word problems to bridge their ability to represent the problem algebraically. Thank you very much. So, you guys saw a question on the overhead projector when you walked in, stating, asking you, what strategies have you used to bolster students' proficiency with the algebra necessary for success at your grade level? At this time, I would like you to, if you have not completed the poster question at your desk, you do have some Post-its and note cards in the middle of your table. Please go ahead and take 30 more seconds and just fill that out quickly while we wait. We've got about 10 seconds remaining. All right, so at this time, I would like you to identify where each grade level is sitting. So 6th grade, can you raise your hand, please? Thank you. 7th? Thank you. 8th. Awesome. Please, everybody, let's stand up and migrate around the room to someone who teaches a different grade level than you and just share out your ideas and thoughts around the question. We got 1 minute. Go. You have about 30 seconds left. 30 seconds left. You guys seem to be sharing some similar strategies. Shocking, right? All right, our time is up. Our time is up. Red Robin. Yum. Thank you. So that will be our kind of call back around. I don't know. I love the commercial. I think it's super fun. And so when I say Red Robin, you say yum, and that will mean that we're bringing our collaborative process to a close. So if we can all return to our seats, you'll see a participant handout at the center of your table. Please go ahead and disseminate those around the table. What we're going to do, you see them labeled, actually notated, pardon me, with grade 6, grade 7, and grade 8. At this time, I would like you to take just 2 minutes, and I'd like you to begin solving those problems with whatever solution you would like to propose. One in particular that you think your students will be would use. And so for the first one, please choose a problem from your grade level. And for your second problem, please choose a problem from any other grade level. Either one above you, one below you. If you're 6th grade, you can't choose below, so choose above. If you're 8th grade, you can't choose above, so choose below. We've got about 2 minutes. Go ahead. Yes, thank you for asking. I'm sorry, this is individual. Yes, this is individual. Thank you. All right, everybody, we have 30 seconds left. Awesome. At this time, please turn to anyone at your table and share with them a strategy for one of your problems that are on your grade level. Let's start there, and we'll do that for 1 minute, and then the other person will be able to share. All right, switch. Awesome. Red Robin. Yum. Thank you. Okay. I heard some very interesting strategies as I was floating around. Some different, some very common. I'd like to take a moment and show you using the grade 6 problem, one way that Eureka Math proposes as a really, really solid model that helps us to approach problem solving for an unknown when we know a whole part. Okay? So let's look at the first problem on the 6th grade level. Hannah is putting in a tile floor. She needs to determine the angles that should be cut in the tiles to fit in the corner. The angle in the corner measures 90 degrees. One piece of the tile will have a measure of 38 degrees. What is the measure of the unknown angle? I saw many strategies that started with drawing an angle, noting that it was 90 degrees, and calling this 38 degrees, which means we need to find x. There is nothing wrong with that. However, I challenge you to see it a little bit differently. So if we draw a tape diagram, we know that this whole part is 90 degrees. That's the measure of our entire corner. The part that we have is 38 degrees. We now support students with understanding that the missing part is called x degrees. Since this makes up an entire unit, we want to add these two pieces together in order to come to the 90. So we have an expression, 38 degrees plus x degrees equals 90 degrees. In order to isolate the x, we want to subtract the 38 degrees from both sides. And we land on x degrees is equal to 52 degrees. So our missing measure is 52 degrees, right? Now, if we take a look at the 7th grade problem, the 7th grade problem asks us something a little differently, but I'd like to show you how we can use the same tape diagram model in order to find the missing piece, okay? So let's just lift this up, okay? Henry is using a total of 16 feet of lumber to make a bookcase. The left and right sides are each 4 feet high. The top, bottom, and 2 shelves are all the same length. Quickly, I just want to note outside, as we start with our read, draw, write process, using the tape diagram for the model, once we read the problem, we want to go through and underscore really important details. There's a total of 16 feet of lumber. That means when I come over here to my tape diagram, I'm going to draw a diagram that equates to 16 feet. That's my total. Again, as I read, it says the left and right sides are each 4 feet high. Left and right. That denotes that I have 2 sides that are 4 feet high. This last part might in fact become pretty jumbled for your students, but let's parse it out for them. The top, bottom, and 2 shelves are the same length. So we want to find the length of each one of those shelves. Okay? There are 4 shelves total, which means this missing part here is going to be multiplied by 4. So I have a quantity of 4x in the middle. Using the same idea of adding to the whole, I come up with 4 feet plus 4x feet plus 4 feet equals 16 feet. I combine my 2 like terms, 8 feet plus 4x feet equals 16 feet. I subtract 8 feet from both sides in order to isolate my x. And I have 4x feet equals 8 feet. Finally, I divide both sides by 4, leaving me with x feet equals 2 feet. Supporting students with a closing statement, I would say each shelf is 2 feet long. Take 2 minutes and discuss in your groups how that tape diagram model of a whole with parts and finding the missing value can support your students from grade 6 through grade 7, and if we have time, we'll finish with grade 8.